Alright. So on number 2, we did number 1 outside. Let's look at number 2. 120. And every fire drill will be like that. Lockdown, if I know it's not a real one, we'll be in the corner with my whiteboard teacher. I'm just going to tell you that now. Yes, I do that every time. Okay.
It's a real one.
Real one, then we will start worrying then. Whenever there's a lockdown, you take your notebook with you and you sit on the floor and open it up. That's what we do. Alright, 120. Alright, what quadrant is 120 in? 2, okay. How do I find the reference angle for 120? Very good, and that's 60 degrees, okay. What is my ordered pair for 60 degrees, Connor?
1.5.
Say it with confidence, you're right. Very good. Common mistake students make, guys, is they don't go back and look at this quadrant number and make sure the signs are correct, okay? Quad 2, your x is what?
Negative.
And your y is?
Positive.
You want the secant, so I need to do what? Don't change your sign, you just flip it. So it's going to be what? Negative 2.
Negative.
Okay. Didn't we do this one outside? I think it's quad 4 is 45 degrees. In quad 4, your x is positive, y is negative, and sign you want with what value? Y. Alright. Now, tangent negative 5 over 4. Change it to mixed number. How many times is 4 going to 5? 1 and 1/4. And we're going to do negative 1 and 1/4. Okay, so we got to go a distance of 1 pi. Now we're going opposite, aren't we? So we're going to go this way. I'm right here. I need 1/4 more. Quad 2 or quad 1? 2, because you're going this way. Does that make sense? If I said 3/4, it would have been over here with. So I'm in quad 2. Alright, pi over 4. In quad 2, my x is negative. And I want the tangent of positive divided by negative is a what? Negative. What's the definition of tangent? Y divided by? Most of the time you have to work that out, but when it's the same value like that, do you have to work it out? Okay. Are there any? What now, buddy?
No mind.
Okay. Okay, you can put that away now. Alright. Now, we're going to review quickly our learning targets. I should have done this outside. Tomorrow you have a quiz on everything that I'm about to show you now. I can identify functions. We already went over a definition. Let's look at these and review this. It says determine whether each relation represents a function. Number 1. It says the input value x is a car's license plate number. I can stop right there because I'm worried about the input. Input is a car's license number. Does any car have the same license plate? So is that a function? Yes, it is. Number 2, does that pass the vertical line test? Yes. How about 3? No. Okay, on number 4 and 5, we have equations, okay? Jason, what do we want to do for these equations? We want to get what by itself?
Y by itself.
Very good. If I get y by itself and I move negative x over, do I have to do any plus or minus?
No.
So is that a function? Yes. But on number 5, I want to get to, yes.
Okay.
This is not in your notebook. This one's going to be a checkpoint, but we're not going to have time to do it. We're just going to give a quiz. So I'm just going over this checkpoint with you, okay? All right. On this one right here, I want to get into that parentheses, but I got to get rid of that square. When you take the square root of something, you have to do what?
Plus or minus.
So would that be a function?
No.
Do you understand why?
Yes, sir.
Okay. Second part, you have 4 of these tomorrow. Find the function value. The number that's in the parentheses is your input, isn't it? So y'all good on those?
Yes.
Yes. All right. If you had to plug 4x in and square it, would it be 16x or 16x squared? 16x. Don't let those little things get you. All right. All right. Next thing I'm going to do is we're going to go over the homework, number 8. What did you get for the first one, Polly? What did you get on 8A? What was your answer to 8A? You didn't do that one? Work on that right now, okay? What did you get? 3. Very good. Very good, Mr. Giles. It's 3. 8A was 3. Good job. Because what's the square root of 0? So you don't have to put that, okay? Got it. All right. 8B, Adeline. What did you get, hon?
3 plus the square root of 9m squared minus 4.
Very good. You cannot, I know it's very tempting to try to simplify that, but 9m squared and negative 4 is connected, isn't it? You cannot take the square root of 9 and 4. Now, if you could have factored out a 9, could you have done that?
Yes.
Yes, but you can't there, okay? But like on C, I want you to look at C. On C, you had to go over and FOIL it, guys. 4m minus 2 times 4m minus 2. And you get 16m squared minus 16m plus 4. I substituted that back in the problem. When I did, plus 4 and minus 4 canceled out, didn't it? And I got to this step, and I'd say, okay, am I tempted to do it? Can I do something here? Yes. Now, I could actually factor out a 16m.
That's what I do.
You can do that. And leave the m under there, that's fine. But you don't have to. I just took a 16 out because I knew I couldn't do anything with that m. So I took that 16 out. Since I took it out, it's not attached to that plus anymore, is it? So that's why the 4's out here. Now, if you got under here m times m minus 1, that's correct as well, okay? Is that what you had, Joseph?
Yes.
That's fine, okay? So you could have that, or you could have 3 plus 4 square root of m parentheses m minus 1. You can have that as well, okay? Is everybody good on that one? You good, Hope?
Yeah, I just can't see.
Oh, I'm sorry. Get out of the way. All right. Now, I love the bottom part. Don't y'all like the function in the bottom? Those are easy piecewise. Okay. I want to find the input value of negative 2. Would that go with the top piece or bottom piece? Bottom, because it says for x values greater than or equal to negative 2. You don't have to show me the work on these if you can do them here. What's negative 2 squared? 4 plus 1 is? Very good. Okay, f of negative 4, top or bottom? Negative 4 minus 2 is? Very good. F of 1, top or bottom? Bottom, because it's greater than negative 2, isn't it? That x value is greater. So 1 squared is? Plus 1 is? Very good. Next one. This x value is negative 1. That would be less than 0. Is there a place to plug it in? No, so it's going to be 3. 4. I'm going to plug 4 into the bottom. That's going to be 1, which is? Now, if I asked you to write that as an ordered pair, how would you write that as an ordered pair? 4, comma. Because isn't that your x value? And that's your y value? That's your input and output. F of 0 would be what? 3. Very good. All right. F of 0. Which one of these does it fall in? The middle one, because it doesn't fall between negative 3 and 3. So 0 squared is? Minus 4 is? Very good. Negative 5 is less than negative 3, isn't it? Is there a place to plug it in? No, so it's 7. F of 3 would be or equal to 3 here. 3 squared is 9. 9 minus 4 is 5. I love those problems. You liking how this homework's coming down there, isn't it? Mm-hmm. You liking that, Noah? We're back under the 45 speed limit. Alright, so turn the page, this page yesterday. We started on notes on this. So let's finish this up. Alright, second period, first period has 5 stars, y'all have 3 stars, just to give you a little update. Alright, so you might want first period is all about it now. Alright. So yesterday we were talking about how to find the domain of functions algebraically. And that means you're not getting a picture. Like in a little bit, I'm going to give you a picture and tell me to state the domain. So you're going to always look at it from the algebraic standpoint and the graphical standpoint. Okay. So right now we're doing algebraic. If I give you a function, how do you find the domain without seeing a picture? That's what we're dealing with right now. So yesterday we talked about there's 2 instances that you have to worry about that. That's when it's rational, which is in the form of a fraction. And what do you have to worry about those functions? Denominator, because we don't want it equal to what? Because it makes it undefined. Very good, class. Then the second one's radicals. Do you have to worry about odd radicals? No, because their domain's all what? Real numbers. But even radicals, it cannot be less than what? In the real world. We're not talking about the complex imaginary world. We're talking about the real world right now, okay? Alright, so when it was a fraction, we set the denominator equal to 0, didn't we? If it was a radical, we set what was under the radicand greater than or what? Equal to 0. When's the only time that you can think of that we would not do greater than and equal to? If the radical is in the what? In the denominator. Because you don't want 0 in the denominator, do you? Does that make sense? Yes,
So that you just act like it's a rational function?
Mm-hmm. Yes, kind of sort of. We do want to just know. All right, now, how do we write our answers in what notation? That's a notation, but not the correct one. Which one? Oh, yes, I sure can. Don't ever be scared to tell me to zoom in. Okay. You're welcome. All right, so, like this one. I set this equal to 0 and got the only value in the world that cannot go in there is -4. So I put an X on it for no, I don't want that one. But then all the numbers to the left and the right could be included, couldn't it? So I had two sets, two areas. So that's why I have two sets in my answer. But I put parentheses around -4 because I did not want to include it. But what always goes around infinity? Parentheses. On this radical, I set it greater than or equal to 0 because square root of 0 is 0. So you can have that. Well, I put a closed dot because it's or equal to and drew the line this way. It's the area. That's the area. It's pointing to the area where the numbers can be found. I call this the brick wall. I built a wall right here that blocks. You cannot go past this number right there, okay? And that's going to play a point in a minute when we see an equation, okay? Another problem. Alright, sometimes you set this equal to 0, you have a quadratic. You might have two numbers. Those are the two no-nos, but I could have these numbers, and these numbers. That's why I have three sets in my answer. Does that make sense? Okay, is that coming back for me tomorrow?
Yes.
I mean, from yesterday. Alright, now we're going to look at these three situations. Alright, on example A, what type of function is that? Rational. So we're more, and this is something, guys, I don't want you to try to memorize stuff. I want you to understand why we're thinking about it. So when you see a rational function, you need to think, okay, I got to worry about a denominator. That's what comes to my mind. And then you say, okay, what do I got to worry about the denominator? I got to worry about what is set when it's equal to what? 0. So think of it like that. Analyze. Don't try to go memorize things. Alright, so I'm going to set this equal to 0. Factor it. A plus 3 and A plus 2. So I got A equals -3 and A equals -2. If you're still having trouble with factoring, please come see me in 0 period. Alright, so I'm going to draw a picture. And, okay, I'm going to say, okay, what is significance of those two numbers? Those are the two numbers I do not want because they make it equal to 0. So I'm going to put an X on both of them. I said, okay, I want to write my domain. So that means all these numbers are here. Good. All these numbers, you say, oh, Mr. Trish, there's no numbers there. You got, yes, I know -3 and -2 is side by side on the number line, but don't you have a lot of decimals and fractions there? So yeah, you've got to include that area. Okay, because there are numbers that I could plug in -2.4 and be fine, couldn't I? And then all these numbers. So you're still going to have three areas in your answer. I don't want these, so what's going to go around these numbers? Parentheses. So it's going to be -infinity to -3 union, -3 to -2 union, -2 to infinity would be my domain on that one. Because these are pit stops in my journey through the number line. So I got to stop there and make a notation. Okay? Alright, number 9. What type is it right now? Overall, general function is what? But it includes a what in it? A radical in the denominator. Now, the only time you have to worry about a numerator is when the radical is in the numerator, but I don't have to worry about the numerator here, do I? Everything, all my eyes should go directly to that denominator. Alright, so I put 2x plus 6 down. And I put a 0. And I got to think, okay, about my symbol. I think about my symbol.
Could you square it and then square the top also, or no?
No, not quite. So, on this right here, you got to think, first off, it's a radical. It cannot have a what type of number under it in the real world? Negative. So I know it's got to be greater than 0. Should I put the or equal to here? No, because it's in the what? You got to think like that, okay? Don't memorize, but just reason through your mind like that. So on this one will be different from this because this was not in the denominator. But guys, this is, so you don't put the or equal to. Does that make sense to you? I want it to make sense, not to memorize, okay? Alright, so I'm just going to solve it. and I get x is greater than negative 3. Remember, the only time you flip an inequality is if I divided by a negative 2. But I didn't. I divided by a positive 2, so there's no need to be flipping anything. So, come here, negative 3, I'm going to put an open dot because it does not have that or equal to. When you have an inequality, you have like a little brick wall that's built. Like the Berlin Wall. You can't go past that, okay? Now, so how many areas am I dealing with here? 1. So you have one set. I got negative 3 to infinity. I know that parentheses always goes around infinity. Since this is open, do I want to include it? So bracket or parentheses. There's your answer. Okay, I want you to take a minute. We're going to come back to 10 in just a second. I want you to turn to page 9 and do 2 and 4. We're going to take a break from the hard ones. I want you to do 2 and 4 on page 9 quickly. This page is right next to you. Yes, sir. Yes. Yes, and that's why you put that parentheses, because that's your that's a good one, but you don't include it. You say that's why.
So 4.
After you work them two, you can conversate with your groups, check to see what your answers.
So 4.
2 and 4, yes, 2 and 4, and see if you get the same thing.
Is this going to be on the quiz tomorrow?
Yes.
Will it be problems like this or problems like
It could be anything that I'm doing today. You talk with your group. Don't be shy to talk. Say, hey, what did you get? Your partner might can explain it better than I did to you. So you talk with your partner. I'll do it for you.
No, not really. Oh, shoot, it is. Wait, it should be.
I'll let you know. I know you don't know how to start. You can make a little presentation. Eventually, by the end of the year, so you don't have to. But right now, have your little visual. All right. So on number 2, what's the one number in the universe that cannot go into that? 3. But everything to the left and right can. So it's negative infinity to what? And what goes around both of them? Union 3 to what? And what goes around both of them? Does that make sense to you?
Yes.
Just remember, I don't want you to memorize. I want you to understand the why. Okay. Number 4. That is going to be quadratic, isn't it? So I'm going to factor that. Be x plus 3 and x minus 2. So the two numbers in the world that can't go in is negative 3 and 2. How many areas am I dealing with? Yeah, so it's going to be from negative infinity to what? 3 parentheses. Union negative 3 to 2 what? Parentheses. Both of them. Union 2 to what? Infinity. Are we good on those? Okay, let's go back to our last one. Alright, number 10. Now, this one right here, we have, okay, first of all, it's rational. And we got to deal with what makes it 0 in the denominator. So t squared minus 16 equals 0. That's the difference of what? So t plus 4 and t minus 4. So I have negative 4 and 4. So those two numbers are no-nos.
So is that 3? That's 3.
What now?
That's going to be 3.
Yeah, I'm not. Where are you talking about 3 at right now, buddy? I ain't got to the numerator yet. Are you talking about the numerator? Oh, you talking about how many sets? Okay. No, we're not finished. This is the only time you got to worry about the numerator. What's in the numerator? Don't you have to worry about radicals? Now, so I'm going to do x minus 3. Would I do greater than or equal to or greater than 0? You would do greater than or equal to 0 because it's not in the what? Denominator. Does that make sense? So, okay, that's supposed to be a t, not an x. Okay, so t is greater than or equal to 3. So I'm going to go to 3, put an open dot, and draw an arrow. Now this is what I want to talk about here. Like I told you a while ago, it's like the Berlin Wall. You can't pass it. That trumps that over there. So you would start right here. You can't go past that right there. Yes, I see you got an X down here. You're not worried about it. It will not go past the Berlin Wall. You got me? So you start right here. Now, let's look at this from here. I do have an X. Do I have to stop at this pit stop and acknowledge it? Yes. So how many sets you going to have? 2. That little area and then the area to the left. Does that make sense? Yes, Hope.
I got lost with the writing stuff down. Where did 3 come from?
Okay, the 3. Well, you got to worry about that radical in the denominator. So I set what's under the radicand greater than or equal to 0. Because, yes, you have rational. You remember you have to worry about the rational situation. And the only time you worry about the numerator is when there's a radical in it. So that's why you had to do that. So here, t is greater than or equal to 3. So I had to come down and add that. If that radical wasn't in the numerator, will we look at the numerator? No. Okay, so closed dot going that way. So it's going to be, what goes around the 3? Bracket or parentheses? So it's be 3, 2, 4. Do I want the 4? So what I go around? Parentheses, union, 4 to infinity would be my domain there. Do not, the Berlin Wall, this brick wall, you do not go past it. If you have this and you start at you don't even worry about anything. Do not go past this. Start here. You got this area, and then you got the area right there. That's why you have 2 sets. Okay. Okay. I want you to go back to page 9 and do 6 and 8. 6 and 8. Number 8, take one thing at a time. Yes, sir.
On number 8, you multiply by negative 1 on the bottom.
No, just don't make it complex. Just say 3 minus x equals 0. Look at it, know that it is. Number 6 is pretty easy. What did you get for 6? Bracket 7 to what? Infinity. Now, while you start number 8, take one thing at a time. Number 8, you have a denominator. You need to set it equal to what? 0. Once you do that, put your number x on that number on the number line. Then come up here to the numerator, take what's under the radicand, and set it what? Greater than or
equal to 0.
Yes, you would do greater than or equal to because it's in the numerator. Do you see that? Continue on. You should get something that looks like that. Watch your mouth. It's very close. I'm sorry if you didn't say it. I thought you did. Now, how many areas would you have to write here? 2. This one and this one. So it would be what around negative 2? 2, 3. What goes around 3? Union 3, 2. Because 3 is a no-no. You start at that stone wall right here. Write this set and then that set. Is it making more sense day 2? Okay. If not, you need to come to 0 period. Okay? Okay. That is on your quiz tomorrow.
Yes, sir.
Alright, we're not done. Turn to page 11 now. Sorry, we got behind on fire drill. We won't get as far as first period. First period did 3/4 this page. Alright, the second learning target. The second learning target today is I can evaluate functions by using a graph. This is very simple, and that's how I'm going to end the day on number 1 and 2. You know how we've been evaluating functions by plugging into the rule? Well, this is, now we did it algebraically, now we're going to do it by graph. In graph, you just look at the picture. It's very simple. Okay? Like, on f of negative 5, this is your input value, isn't it? Your input value, is that your x or y coordinate? X. So what you do is you go to negative 5 on the graph and go up to where you reach. What would that y coordinate be? 8. That's all you do on this. So, negative 5 up to 8. Okay. 0. Go to where it's 0 on the x-axis. Go straight down. Where's that? X value is 2. 2 straight down would be what? Negative 3. Oh, I'm going to tell you, I apologize. The graphs that you're going to have on your worksheets, quiz, and test will be better. You will actually see the grids, okay? So we're
Did you go up on the next one?
What now, buddy?
On this one, where'd you go up?
You're talking about F5? Yes, like I go to X, go up to what? 1. So basically, you're just finding the Y value that goes along with the X value. Does that make sense? If I was to ask you to write these in ordered pairs, how would you write that? Negative 5, comma what? 0, comma 2, comma 5, comma 1. So basically, these are your X values, and you're just trying to find the corresponding Y values. Okay, let's look at another example. F of negative 7, I go to negative 7, straight up. What's my Y value? 6. F of negative 2. Okay, this is an interesting one, guys. I don't know if you saw this last year, so let's talk about this. My X value is negative 2. I go up there, I got 2 dots. Which one do you think you would include? You would choose, did it? Yes. Why would we choose 4 and not the 6? It's a closed dot. Does it closed mean it's included? Open dot means you wouldn't include it. So yes, you would choose 4 on this one. It's not defined at an open dot. Okay, 1 would go up to almost 1. We're going to say that's 1. And then 3 is what? 3. Very good. Your homework was on that same page. You just did those 4. Do everything but the challenge problem, okay? Page 9, you're just doing that domain like we did at the beginning of class. That's all you practice this time. We will go over that before the quiz tomorrow, okay?
So do page 11 or don't?
You're doing page 9. Page 9 was the one that you just did the 4 problems off of with the interval notation. Does everybody understand what page we're doing? We're going to finish this tomorrow after the quiz. Okay? Have a great day.
Are we having a homework check tomorrow?
Homework check will be tomorrow, yes.